Welcome to another lecture on Java. Today we are going to look at the JVM, and this is purely a theoretical lecture. And under this topic, we are going to look at the following contents: the Java virtual machine, the JVM language, Byte-code, class loading, class loader subsystem. So it is important to note that the JVM itself it's an abstract machine. It's a specification, and we have different implementation of it. Like we have Oracle JDK, we have Open JDK, which is now maintained by Red Hat. We have Amazon implementation, IBM, Azure, and many others. For instance, if you go online and Google Java SE specification, JSR, you'll find a document like for Java 19. You'll find a document that outlines the specification for Java version 19, how it has to be implemented. Then the JVM languages. It's important to know that besides Java, we have other languages that can run on the Java virtual machine, like Scala, Kotlin, Groovy, Jython, and JRuby, and others that I didn't mention. Then the bytecode. As we mentioned in our previous lecture, that the bytecode is like an intermediary, or you can almost say it's the language of the JVM. It has its own structure, and the JVM knows how to read it. So in computing Java bytecode, it's a bytecode structured instruction set for the JVM, a virtual machine that enables computer to run programs written in the Java programming language and several other programming languages. This definition comes from Wikipedia. So on the left, it's the structure of how a JVM a bytecode would look like if you were to have a view of it. These are just instructions to tell the JVM what to do. Then we also have one important aspect of the JVM called class loading. So the Java class loader is a part of Java runtime environment that dynamically loads classes into the Java virtual machine. And the Java runtime system does not need to know about files and file systems because of class loaders. Java classes aren't loaded into memory all at once, but some are loaded when they are required by an application. And at this point, the Java class loader is called by the JRE, Java Runtime Environment, and these class loaders load classes into memory dynamically. We have different class loaders. We have Bootstrap class loaders, which actually loads the core Java libraries. You know that when you use string and other classes, maybe I think the wrapper classes, you don't need to import them. It's because they are automatically loaded for you by the loaders into memory. Then we have extension class loader, load classes from the java.extension directory, system class loader. This one actually loads from the class path, the developer's application class path. Class loader subsystem. So the class loader subsystem is divided into three. We have the loading phase, the linking phase, and the initialization phase. And as you can see, each phase has different stages or processes. So the loading phase. Loading is the process of finding the binary representation of a class or interface type with a particular name and creating a class or interface from that binary representation. The class loader is an abstract class, and when it's given a binary name of a class loader should attempt to locate or generate data that constitutes a definition for the class. A typical strategy is to transform the name into a file name and then read a class file of that name from a file system. The class loaders. We mentioned that we have bootstrap, we have extension, we have application. So what is a bootstrap? As we've said, first bootstrap class loader. A bootstrap class loader serves as a parent of all other class loader instances. It is also called the primordial class loader. Its main responsibility is loading JDK internal classes, typically found in the rt.jar and other core libraries located in the Java home JRE lib directory. And additionally, the bootstrap class loader serves as a parent of all class loaders, as we have mentioned before. The extension class loader. The extension class loader is a child of bootstrap class loader and loads the extensions of the core Java libraries from the respective JDK extension library. It loads files from JRE lib extension directories or any other directory appointed by the system property java.extension.direct. Then we have application. An application class loader is also known as a system class loader. It loads the application type classes found in the environment variable class path. You can mention dash class path or dash CP on your command line variable. The application class loader is a child of an extension class loader. So if you look at, let's just open our IDE. When we run this, we will notice that we have provided the class path here. It's just that the IDE will do things for you. That is why when you're learning Java, it's recommended not to use an IDE, to use command line so that you know what's happening behind the scene. So this is a direct action for it's an application class loader. You are telling your Java to locate specific classes that are required for your application to run. And we have under class loader subsystem we have linking. And linking a class or interface involves verifying and preparing that class or interface, its direct superclass, its direct super interfaces, or its element type if it is an array type if necessary. Resolution of symbolic references in the class or interface is an optional part of linking. And the specification of the JVM allows an implementation flexibility as to when it should activate the linking activities. And this linking has actually three phases: verification, prepare, resolve, or resolution. Then the verification reads the bytecode and ensure that code adheres to Java semantics, correct binary format, and does not violate rules or will not compromise the JVM. And also check for compatibility stuff. If the rules does not hold, then the linking error must be thrown. The specification says that error must be thrown. The prepare phase is actually for memory allocation for class variables, static variables, not for instance variables. Static variables are given default values. Then the resolution, it's actually where all symbolic references are resolved, and such as references to other classes, values in the constant pool, and a change from symbolic references to actual references also happens here. Symbolic reference resolution is open to vendor specific, so a vendor is open to do its own implementation. Then we have the initialize phase. This is actually the point where the class is first made ready for use, and the class variables are now given actual defined values by the programmer.